What I love most about stop motion is that everything you see on screen exists for real and it was handcrafted by an artist, and you can spot the fingerprints and scratches and tool marks on everything. But there are some modern manufacturing techniques which make things just so much easier that I really don't want to miss them anymore. So in this video, let's talk about 3D printing for stop motion animation. Hi, I'm Valentin, and my #1 use case for 3D printing on my project was something which isn't visible in the movie at all actually, and that's molds for silicone parts. You see, most of our puppets need to be soft and flexible for animation, but elastic 3D printing materials just don't work for delicate high-resolution prints yet. But what you can do is to print a rigid mold and use that to cast as many silicone parts as needed. In the past we have used various plaster molds, which worked okay, but the sculpted positive could never be used for more than one mold. It was hard to iterate when dimensions weren't perfect, and when a mold breaks, it's nearly impossible to reproduce perfectly. Also, if an armature has to fit neatly inside, it can be super difficult to sculpt perfectly, as you can't really see how it fits, of course. And that's where digital 3D modeling really shines. We were able to import the armature geometry from CAD and then see exactly what we're doing when shaping the fingers around it. From all the techniques we tried, high-resolution SLA printing works best in this case, but home-grade resin printers can also do a surprisingly good job. As you can see, the printing layers are nearly invisible and you can get some super fine details out of this. It's important to design the parts without overhangs, as any support structures would ruin the smoothness of the mold surfaces. But that's usually a requirement for molds anyway. To make sure the two halves of the mold meet perfectly, I recommend to sand down the meeting surfaces on a flat sheet of glass. This corrects for any warping which might have occurred and also makes sure the edges are sharp and flat, minimizing the visible seam lines on the final silicone parts. During casting, it's also super important to hold the armatures floating perfectly in the center of the mold to not touch any of the outside surfaces. And to achieve that, we attached some holding blocks on the arm ends of the hands. Next up, something a bit more straightforward, so-called volumes. Most puppets will need some sort of rigid shapes between the inner armature and the outer skin or clothes layer. This gives them their shape and also incorporates some solid touch locations for safe handling during animation. It's also possible to integrate some rigging system into the same parts. Many materials have been used for this purpose in the past, like balsa wood, hard foam, hardening clays, as well as fiberglass shells and cast aluminum parts, but none has been as versatile as 3D prints. We used this first on our boss character to shape his belly around this breathing mechanism in his chest. Please check out this video to see more of that. It was very convenient being able to incorporate a screwed connection directly into this 3D prints instead of gluing something onto the brass, which would have left us in fear of breaking loose mid-animation. For this use case, basically any 3D printing technique will work, but classic FDM seems most appropriate because it allows you to create hollow parts to save on weight, which can be very valuable, especially on larger puppets. Recently I was commissioned this tortoise armature, and here I ended up using nylon SLS printing to create its hard shell. When you make puppets only for yourself, it can be much quicker to sculpt it manually, of course, But as soon as you're working with a team or customers, it's just much more convenient being able to sculpt it virtually first and only print it once its final shape is approved. Also, if you need multiple copies of the same parts, it's just much more convenient that way. Now, I always get asked, which kind of 3D printers do I own? And the answer is surprisingly none at all. Because in most cases I have some very demanding requirements regarding the resolution, strength or materials of my parts. And it's just not feasible for me to own any industrial grade 3D printers. So luckily I don't have to, thanks to great manufacturing services like my sponsor PCBWay. If you would like to try out some of the techniques from this video yourself or need any other complex components you cannot make yourself, PCBWay has you covered. They offer all sorts of 3D printing and CNC machining services, as well as their core discipline of PCB circuit board manufacturing, of course. Just recently I received an exciting package from them, including my new prototypes for the miniature light controllers, already populated with tiny SMD components, as well as this laser-cut acrylic sheet part, which I designed to hold my assortment of 5C collets. Fits perfectly. It's so satisfying finally having a nice and accessible way of storing them, and I think the transparent sheet makes it look even cooler. PCBWay has been super easy to work with and the manufacturing quality is very satisfying. Please check out the website at pcbway.com or follow the link in my video description if you're interested. And now back to 3D printed body parts. What first comes to mind when you hear 3D printing and stop motion together are probably the faces of Leica's puppets. And indeed, 3D printing can be a perfect solution if you want to create complex facial expressions with replacement animation. When we faced the challenge of getting our boss character to eat and chew, we quickly realized that replacement animation is probably going to be our best option. So, Puppetmaker Ulrich created about 30 mouth expressions in Blender, which also allowed us to do some crude animation tests even before printing them. Besides the mouths, there's also a main headpiece, which provides a mechanical interface to attach the replacement parts, which are held in place with some tiny magnets. In theory that's all easy, but Ulrich's old resin printer was just not up to the task and produced visible lines between layers in regular intervals and stuff like that. And I couldn't afford this quantity of industrial SLA prints. But luckily one of my patrons was here to save the day, so huge thanks to Thomas Meissner for helping us print all the head and mouth pieces on his Dental Lab 3D printer. I actually don't know how this technique is called, but apparently it's a DentaJet printer and the parts look and feel just like a piece of ceramics. Absolutely brilliant. And also quite fitting to print the teeth of our character from real fake teeth material, I think. To hide the last bit of printing texture, we sanded the parts a tiny bit and then painted them with airbrush to make them look as similar to the other characters' silicone faces as possible. With directly visible 3D prints, it's also a stylistic choice to use them or not, because it will always be visible to some degree that these weren't sculpted by hand. But there are some tricks you can do to make them feel more organic. For example, using as few replacement poses as possible or introducing some variations in the texture and painting between those poses. Recently I had the chance of seeing a perfect example of this in real life when I was visiting the stop-motion video game production Out of Words in Denmark. I link to one of their videos in the description, please check it out. Their puppets are the nicest I have touched so far, and I had the honor of contributing some hand armatures and other small mechanisms to this marvelous game. Originally, I also wanted the boss character's face to be made of silicone, to have the same look as the other humans and a flexible wobbly chin. So the first version we tried only had 3D printed skull pieces, which would be covered in a layer of silicone, which would in turn be cast in a 3D printed mold. But sadly, it didn't work out with the techniques available to us at the time. If you would like to witness the entire failure, I highly recommend you check out the update videos from March 2023 onwards, where I showed our progress on a monthly basis. Links in the description as well. With stop motion, each shot is a new challenge and often requires you to improvise little fixtures or mechanisms to get it done. And if it's just for 1 or 2 shots, a 3D printed winder might save your day. But in general, I've not been impressed with 3D printing for any mechanical applications so far. It's not so much about the strength of the parts as it's about their precision. Thing is that even industrial grade printing techniques have huge tolerances compared to CNC, and usually they leave some rough surface textures, which create a lot of friction, leading to uneven movements and such. Being an armature maker, I was sometimes asked if these complex mechanical joints couldn't be just 3D printed nowadays, but the answer is simply no. Nevertheless, I am also intrigued by the idea of 3D printing metal, and I was really excited when I had a good excuse to try it out in my daily work. But before revealing that, I would like to offer you some more delicious free content. If you would like to stay updated on my project and work in general without relying on the magical algorithm, then I highly recommend you subscribe to my old-fashioned email newsletter or follow me on Patreon. The latter just launched a new home feed with posts from all your favorite creators, and while the insufferable decline of social media continues, this seems like a nice place to enjoy some art in the meantime. Please give it a try, and if you would like me to continue making videos like this, please consider supporting me on Patreon as well. It really makes a difference for me. And now back to my experiment with 3D printed metal. As you probably know, I make these tiny articulated hand armatures, and the most annoying part about them has always been the palms, because they're so weirdly shaped with lots of features at inconvenient angles. And so in the latest batch I tried to have them laser sintered from stainless steel, and this is the result. The material is really solid, no pores inside, but the surface is rough like sandpaper and just cannot define any precise mechanical features. So I treat this like a rough casting basically, and then machine all the important geometries manually. A CNC mill could do a better job for sure, but without one, the 3D printed palm really saves me some work, and most importantly, it allows me to consider even weirder, more complex organic geometries for future projects. So, what are your thoughts about this? How do you use 3D printing in your work, or what would you like to try out with these techniques? Please let me know in the comment section down below. And if you made it that far, please also leave a like and subscribe so the algorithm notices me. Now, thanks a lot for watching, have a lovely day, and bye bye.